Hello and welcome. In this video we'll be taking a look at case recoveries in the RAZBAM AV-8B Harrier 2. Before we get into video procedures, we need to look at the theory side, so let's get into that now. So this is a breakdown from the manual and what it briefly summarises. The delta pattern. The delta pattern is a VFR pattern orientated overhead the ship with left-hand turns. Next is a TACAN primary marshal, which means stacking the aircraft on the 180 bearing relative to the BRC, basic recovery course, at a specific altitude. This pattern uses ship's TACAN or farther for correct positioning. TACAN overhead marshal is an overhead holding pattern with the inbound leg being 210 degrees relative to the BRC. The holding pattern is a racetrack pattern flown with 10 nautical mile legs and left-hand turns. Just as for the carriers, there are three main types of landing on the LHA, which mostly depend on the time of day and the weather conditions. Case 1. Case 1 recoveries are conducted when the weather is 3000 to 5, which means the cloud base is 3000 feet above or better with 5 miles visibility or better. A VFR recovery is conducted to the overhead. Case 1 recoveries are the preferred recovery method for day and night VMC operations. VMC standing for Visual Meteorological Conditions. Case 2. Case 2 recoveries are conducted when weather is 1000 to 5 or better, but less than 3000 to 5. During a Case 2 recovery, an instrument approach is conducted in order to reach VMC underneath. Case 2 recoveries are conducted during the day or during NVD recoveries. And finally, Case 3. Case 3 recoveries are conducted when the weather is less than 1000 to 5 or during night unaided recoveries. Case 3 recovery is an instrument approach to a full stop or low approach to enter the Case 1 CQ pattern. Case 3 recoveries shall be conducted under procedural or positive radar control until the pilot assumes visual control. Now I'm just going to go over the three different holding patterns that are used in conjunction with the recoveries themselves. The first two that I will show you are called marshals, and then the third one is just a basic holding pattern around the carrier itself. So let's look into the first one, this one being the TACAN primary marshal. So the TACAN primary marshal is orientated on the 180 bearing relative to the base recovery course. That means it is exactly behind the ship. To determine it, you simply add the base recovery course to 180 or subtract if the BRC is greater than 180. We have a couple of examples. So if BRC is 090, then the TACAN primary marshal will be at radial 270. Or if the BRC is 270, then the TACAN primary marshal will be at radial 090. And then the distance is calculated as follows. For each 1000 feet of altitude, add 1 nautical mile to the base of 15 nautical miles, which will give you the distance from the mother to the holding fix. So if you are told to hold at Angel 7, your holding fix will be 22 nautical miles, 15 plus 7, behind the ship on the given radial. And just to clarify, your hold will actually be a 10 nautical mile racetrack pattern relative to what we've just been talking about. Now I've not actually shown any video of me doing this because it would purely be me doing racetrack patterns, and to be honest, if you can't do a racetrack pattern in a Harrier, you shouldn't be flying it in the first place. So I've just foregone the actual showing of the hold because it's pretty basic, but I've given you the formula to get down to the ship thus far. And the second marshal is the TACAN overhead marshal, and is an overhead holding pattern with the inbound leg being 210 degrees relative to the base recovery course. The holding pattern is a racetrack pattern, again with 10 nautical mile legs, left hand turns, and with the inbound leg passing over the holding initial approach fix, which is 4 nautical miles DME, and the base altitude assigned shall not be less than 6000 feet. The one thing to remember about the overhead marshal is that your holding pattern will always be 30 degrees to the right of the BRC. So no matter which way the ship is facing, just calculate 30 degrees to the right, and your holding racetrack will be relative to 4 nautical miles DME, and then 10 nautical mile legs again, with left hand turns, until you're cleared to come down, which case you'll cross over the top of the carrier and then you'll work your way down into the base leg. Finally, I've left the easiest one till last. This is a delta pattern and is the most commonly used way of getting back on board the ship. All aircraft should remain within 5 nautical miles DME of the ship while flying it, and maintain the assigned altitude given until cleared to come down. Just left hand turns, and as long as your tack hand is on and you remain within 5 nautical miles of the ship, you're good basically until, like I say, until you're cleared to come down. At last we come to the first of our case recoveries. So case 1 recovery is the most standard way of getting back to the ship, performed during day and night operations if weather permits. It closely resembles the standard recovery for the aircraft carriers. All recoveries are made using vertical landing. So as you can see, we start at number 1, obviously, at the gate. Now this is the start of the whole procedure. It starts 12 nautical miles behind the ship and at 1,200 feet. Now once we get to 3 nautical miles DME, we want to be 800 feet from the sea level, and we want to be starboard side of the ship for the initial. Maintaining 800 feet and travelling at 350 knots, we will need to count 10 seconds as we pass the ship to perform the brake. As we perform the 180, to get downwind, we want to bring the aircraft down to 600 feet and pull 10 to 12 units of angle of attack, all the while throttling back, decelerating below 250 knots. Once we beam our landing spot, we will want to perform our landing checks, switch anti-skid off, external lights off, and the distance from the ship should be no greater than 1 nautical mile. Now turning on to base leg, we will want to put our nozzles to 50 to 60 degrees, and if the wind is greater than 20 knots, we need to turn prior our landing spot. If the wind is 10 to 20 knots, we need to turn beam our landing spot, and if the wind is less than 10 knots, we need to turn after 2 to 4 seconds passing the landing spot. Once we're at the 9E, we need to be 400 to 450 feet off the sea and pulling 10 to 12 units of angle of attack. Now this is when things start to get a little bit tricky, because remembering that the ship is moving, so it's not as easy as you'd think. We need to get into what is called the groove. Now that's 300 to 325 feet off the sea, and needs to be performed half a nautical mile to 3/4 of a nautical mile astern. Then we can enter the hover stop with a 3-degree glide slope. Once we're abeam our landing spot, we need to be 100 to 120 feet off the sea, and we need to be 1 plane width away from the deck. When abeam, we can perform our level cross. Once above the deck and over our landing spot, we need to perform a 50-foot hover, and then we can perform the landing. Remember that the ship is constantly moving forward, so we need to match the speed of the ship, as well as trying to create a hover, which can be very disorientating if you're not used to it. Once rubber hits still, remember to throttle back to idle as soon as possible, holding full brakes. Then you can perform nozzle aft and turn the water off if used. Now let's jump into the cockpit and see it in action. First thing we need to do is tune in the TACAN and enter it onto the MPCD and bring the DME up on the HUD. Make sure our altitude's at 1,200 feet for the gate. There's the tower. going to position myself on the right hand side of the ship. Bringing the aircraft down to 800 feet as we get nearer to our 3 nautical mile DME.
Caution, caution.
Okay, so we've hit 3 nautical miles, so we're now at the initial. So we'll start our count down from 10 now. Make the turn, throttle back, pulling 10 to 12 units of angle of attack and bringing it down to 600 feet for the downwind. As we are below 250 knots, we can bring down the gear, lower the flaps and switch the water to landing. Do our landing check, switch on the nozzle steering, turn off the lights, clear caution. About to make our turn to base leg, we can bring our nozzles down to 50 to 60 degrees, making our way to the 90 where we need to be around 400-450 feet. And then we can start working our way into the groove. Now we're going to put the nozzles to the hover stop and get ourselves into the groove. This can be a bit fiddly as we are now transitioning from wing-borne to jet-borne flight, so you need to be on the ball. Now I literally get stuck in the groove here because I matched the ship's speed a bit too early, so just beware that you can let the ship get away from you if you slow down too quickly too soon. And as we get close to the ship, this is where we could do with a binocular rivalry, where we could move individual eye in a position we wanted, so I could have one looking at the deck and one looking at the instruments, but we need to watch for the deck and watch our instruments and make sure the nose doesn't dip and we don't climb. It gets very fiddly here, so trying to get as close a beam to the parking spot I want. Start to perform the level cross over to a landing spot. Bringing it down into a nice slow descent. Touchdown, throttle back, brakes fully on. Nozzles fully aft. Water off. And now using the nozzle steering high gain, we can now taxi back to our parking spot. So that's case 1 recovery. Pretty simple in the grand scheme of things. Obviously the easiest one out of the 3 case recoveries. So yeah, it's just matching the ship's speed, being able to look at the deck and look at your instruments and keep the aircraft flying level. That's the difficult part. So let's get on to recovery 2. So the case 2 recovery is flown in a similar manner to case 1, with several differences with regard to altitude. So instead of coming down to 600 in the beam, we maintain the 800 from the initial. So we start at the gate again at 12 nautical miles behind the ship at 1,200 feet. Then as we approach the initial at 3 nautical miles behind the ship, get down to 800 feet, 250 to 300 knots and to the starboard side. 10 seconds after passing the ship, we perform the brake, 10 to 12 units of angle of attack, and we maintain 800 feet. As we get a beam, we do our landing checks, switch anti-skid off, external lights off, and make sure that the distance between you and the ship is less than 1 nautical mile and at 800 feet. Then we make our turn onto base leg, nozzles at 50 to 60 degrees. Again, if the wind is greater than 20 knots, turn prior to your landing spot. If the wind is 10 to 20 knots, turn a beam, and if the wind is less than 10 knots, turn after 2 to 4 seconds passing your landing spot. In the turn, once we get to the 90, we need to be at 650 feet, pulling 10 to 12 units of angle of attack. Now we get ourselves into the groove, 500 to 550 feet above the sea, 1.3 to 1.5 nautical miles DME, and if you are talking on comms, the pilot calls Harrier ball or Clara. 0.5 to 0.8 nautical miles DME will bring the nozzles to the hover stop. Once a beam to the landing spot, we need to be 120 feet off the sea, 1 plane width away from the ship, and when a beam, perform the level cross. Once over the landing spot, perform a 50-foot hover, and then we can bring the throttle down to perform a vertical landing. Remember that the ship is constantly moving, so you need to maintain the same speed as the ship. On touchdown, we need to bring the throttle back down to idle power, putting on full brakes, then the nozzles to aft, and then we can switch off the water if it is used. So like before, we need to tune the TACAN in, and make sure that it shows up on the MPCD and also on the HUD. So we're approaching 12 nautical miles and we're getting to the gate. We're at 1,200. going to switch the HUD to VSTOL mode. Slowly bringing the altitude down to 800 as we approach the 3 nautical mile initial. Placing ourselves starboard side of the ship, no further than 1 nautical mile. Counting down from 10 now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, brake. Into the turn, throttling back 10 to 12 units of angle of attack, and maintaining 800 feet if you can. We're now below 250 knots. We can now deploy the landing gear, the flaps down into stall, water to landing, nose wheel steering on,
Caution.
external lights off,
Caution.
nozzles down to 60, clear the caution, and then we can make our turn to base leg. Again, this is performed if wind is greater than 20 knots, turn prior to your landing spot. Wind is 10 to 20 knots, turn a beam, and if the wind is below 10, turn after 2 to 4 seconds after passing. At the 90, we need to be around 650 feet. Move the nozzles into the hover stop. Now that we are fully in jet-borne flight, we need to juggle all the control surfaces to keep ourselves level and get ourselves into a around about 120 feet off the sea. As we come a beam to the landing spot, we need to be one plane width away so that we can perform our level cross. Again, this is where binocular rivalry would really come in handy, as we need to watch the deck, need to watch the instruments, we need to watch the direction of the aircraft, make sure we don't get into a nosedive, make sure that we don't start to plummet, and just bring ourselves up a beam to our parking spot. going to start performing our level cross over to the landing spot. Using right aileron and left rudder to keep the nose pointing in the right direction. Bringing it down into a nice slow descent. Once rubber hits steel again, we need to throttle right back to idle as soon as possible, brakes fully on. Then we can put our nozzles fully aft, we can switch the water off, and we can put our flaps to cruise, and using the high gain we can then taxi to our parking spot. So that's a case 2 recovery. Like I said at the beginning, it's not too dissimilar to a case 1, just a few changes in the altitude and distance for the groove. That's it really. So hopefully that's covered that one nicely, and we can now start thinking about case 3. As you can see right off the bat, case 3 is completely different. The case 3 recovery is different to the others as it relies too much extent on instruments and landing aids. Depending on the weather conditions, case 3 may be an instrument approach to full stop or a low approach to enter case 1 pattern. The most common pattern used for the case 3 would be the TACAM primary marshal. Now, I'm doing an unaided nighttime recovery, so there will be no external help. It will all purely be instruments on the Harrier and the Mark 1 eyeball basically. So yeah, that it will differ slightly, as I will not be using external factors to get the Harrier onto the deck. Prior to the gate we need to set the APU to on and the radar altimeter to on. Then as usual, the gate is at 1,200 feet above ground level at 12 nautical miles DME. At 5 nautical miles DME we have something called the final approach fix, which is 1,200 feet above ground level and performing the landing checks. At the 3 we need to be down to 1,000 feet. At the 2 we need to be down to 700 feet. At the 1 we need to be down to 400 feet. At 0.5 to 0.8 nautical miles DME we can put the nozzles into hover stop, maintaining 400 feet. At the ramp you need to be 45 to 50 feet above the deck, and then over the spot 45 to 50 foot hover, and then after touchdown the usual, straight to idle, full brakes and nozzles aft. So before we get into the video I just want to mention a couple of things. First one is I couldn't get any of the comms to work between the Harrier and the Tarawa so that I could get the V-stall optical landing system to work. So I couldn't perform normal case 3, which would be straight over the deck and down. So it brings me on to the second thing. It's slightly different with mine. I've come a beam and done a level cross straight onto the parking spot. So there is that to take into account. If anybody can point me in the right direction on how to get the V-stall optical landing system to work, that would be fantastic, because it's really starting to bug me. And with that, let's get into the video. First things first, let's get the TACAM tuned in and mark it to show up on the HUD. Now I'm going to input the BRC of the ship using the course switch 300, enter, and there we go, we have our BRC. Just going to position myself on course before we approach the gate. Descend down to 1,200. Level off at 1200 so that when we hit the gate we're at the right height. Now we're through the gate, I'm going to switch on the APU and the radar altimeter. Switch on the nose wheel steering.
Caution. Caution.
Clear the caution. Now we're just waiting to hit 5 nautical miles DME for the final approach fix. Some of you may have noticed that on my right MPCD that I don't have the flare on. That's just simply because it causes too much glare, so I've kept the RWR on. That's us at 5 DME. Now we can slowly descend to 1000 feet for when we hit 3 DME. We're now at the 3. We now need to descend to 700 feet AGL before we hit 2 DME. We can now deploy the gear, flaps and switch water to landing. Nozzles to 60 and now we're at the 2 DME. HUD over to V-stall mode. Now the objective is to hit 400 feet as we pass the 1 DME. Now we're at 1 nautical mile DME, we can think about putting our nozzles into hover stop, and we now need to keep ourselves at around 400 feet, trying to match the ship's speed and getting the beam our landing spot. I like to approach the deck at around about 200 feet, so that when I get a beam, my landing spot ready for the level cross, I'm at a fairly decent height that I can see what I'm doing, and also have that little bit of height for safety. So I'm approaching the landing spot, almost a beam, and we'll perform the level cross. Pretty much the same procedure as case 1 and 2, about 150 feet, and moving over using the right aileron and left rudder to get over to the landing spot. Get ourselves positioned, and then we're going to slowly descend, and then it's the same procedure again. As soon as the tyres hit the deck, throttle back as quickly as you can with full brakes on, and then you can put the nozzles fully aft and switch the water tank off if you've used it. And there we go. And now we can use the high gain on the steering to get us to our parking spot. So that was a case 3 approach. Again, the difference being I came a beam and did a level cross rather than coming straight in, simply because I can't get the V-stall landing lights to work. So yeah, it's something I'm going to need to read more into, but I can't find anything about them anywhere. So yeah, if anyone knows, please let me know. That'd be great. Now, speaking of the vertical short takeoff and landing optical landing system, or VSTOL OLS, it's an instrument providing the visual glide slope and trend information during the fun portion of the case 3 landing. It is mounted above the deck on the aft end of the island and is deployed aboard LHD and LHA class ships. So number 1 on the obvious photo here is a green datum light bar. Now these are mounted exactly in the middle of the indicator. 2. Indicator with amber ball. Depending on positioning of the approaching aircraft, the ball moves up and down. If the amber light is in the upper portion of the indicator, the pilot is above the glide slope. If it is lower part, it's obviously the pilot is below the glide slope. Number 3, this is the LSO lights used to send signals to the pilot. So wave off will be a flashing red, power a flashing green, a cut call is a steady green, and bingo is an alternate flashing red and green. Glide slope indication is set for 3 degrees in order to bring the pilot to the ship's ramp with his eye approximately 50 feet above the deck. So you can see it would be quite handy if I could actually find how to get these working. But I reckon it's just me that's the problem here. Now for one that's not in the manual, but what I believe is practiced by the United States Marine Corps and is certainly and was certainly used by the Royal Navy when we had Harriers, the Ship-Borne rolling vertical landing. Now coming back to the carrier, we the Royal Navy would fly back with munitions, as we don't dump our munitions because it's too expensive, whereas the Marine Corps and the United States Navy, I believe, have a bit more leeway in the matter. So I'm coming back to the carrier. Vertical landing wouldn't be viable, so this is an approach that isn't a short landing, it's not a vertical landing, it's in the grey area between the two. So basically I've set the aircraft up, got the gear down, got the flaps down, got water tank set to landing, I've got the TACAN tuned in, I have the BRC tuned in, and I have the nozzles at 60 degrees and making a slow approach. Also making sure that the nose wheel steering is selected and the HUD mode is in V-stall. We're basically just making a nice slow steady approach, try not to lose too much height and not to go too fast. And this, as I said previous, this would be great to have the optical landing system up and running, but again I couldn't get it to work, so I'm just judging it by eye at the moment, keeping the tower basically in the slip indicator on the HUD, and yeah, just trying to keep it below 100 knots until we get to a little bit closer. Then we can start making little increments to the nozzles, slowly bringing it to the hover stop, so that when we're over the deck we are virtually trying to get into the hover, but we will be landing at that point so that we're still rolling forward ever so slightly. And I've moved the nozzles to 73 degrees just to bring the speed down a bit more, and also, just keeping the altitude steady as we approach. And I've now gone into the hover stop, see if we can drop some more speed. And also just we need to throttle up to keep the Harrier descending slowly and not to drop too much altitude. and it'll be a matter of, as soon as we hit the deck, throttle straight back, full brakes on, and nozzles aft. Then it's just a matter of cleaning the aircraft up, making sure everything's back how it should be, and then we can use the high gain on the nose wheel steering again to get to our parking spot. So that's the Ship-Borne rolling vertical landing. Just a little extra threw in. It's probably not by the book, but it's quite a handy one to have if you're coming back with a heavier load and can't do a vertical landing. So that's the end of the video. All the case recoveries plus the marshals, a delta pattern plus my Ship-Borne rolling vertical landing. I hope that's helped. If anyone can get back to me on the optical landing system, that would be great. And as usual, if you got this far, thank you for watching, take care, and I'll see you in the next one.